So when we ask what are the big challenges that we now face in cosmology, it's actually interesting because when we discovered the expansion of the universe is accelerating, that was about 20 years ago, it looked very, very difficult to learn more because the differences between all of the hundreds and thousands of theories that might explain it were very, very tiny. It was very hard to tell any of the differences if you actually went to do a measurement. And for the entire 20 years since then, we've been identifying and inventing ways to make that measurement much, much more precise. What's amazing is that we've succeeded. Now we have techniques, and I didn't know that we would definitely get there, but now we are ready to make the next generation of measurements. It took 20 years to build the new instruments, to build the new telescopes, to check the techniques and learn how they work. But now we have them all in hand, and the next 5-10 years is going to be the time in which we get to try this next generation of measurements. So I'm actually optimistic that we may be about to learn the next chapter in the story. And it's an exciting time to do cosmology. I mean, we never know whether we get to see the answer. All we know is that you have to make the measurements and try. And so far, every time we made a big advance in cosmology, we found new surprises and we've learned something new. And I don't think we finished that yet. So since this next 5-10 years, it's a whole new range of experiments and a whole new set of observations that we'll take. I'm sort of betting that we will get to learn something. Of course, last time we learned something new, it just opened up new questions. It could be the same. Maybe we'll learn something new and there will be even more questions that come out of it. But possibly we'll learn some answers. For me, one very important aspect of science is that it's a way of thinking about problems in the world that's very, very humble in a certain way. It's proud that because if you work with a lot of smart people and over many centuries, you can discover things that no human should be able to discover. So it's amazing what we can learn. But it's humble because the only way it works is that you have to assume that you're making mistakes. You have to assume that you're wrong about something. And so that means that you can't approach problems by convincing everybody else that you're right and they're wrong. You have to approach problems assuming that you're making a mistake and that other people can help figure out the mistake together with you. And I think that's the fundamental starting point that would help our whole society for all of our problems, that we need people to come together, not convinced that they know the answer, but assuming that they must be making some mistake somewhere and that they're open to learning with each other. I think if we learn how to teach that together, that scientific style of critical thinking, where you look for the mistakes and your own mistakes much more than you look for other people's mistakes, then I think it makes it possible for people to work together because they feel more welcome to join each other in the conversation. And when you get people solving a problem together, I'm not worried. I think then we will solve climate change, we'll solve energy problems. I think we'll be amazingly capable. But right now, I think people have not learned how to do that very well yet. And I'm hoping that the science can act as the example to help people do that.